me talk through like 1 through like this first bit here. Two things that are not mutually exclusive. So mutually exclusive and complements. So I just put like some notes about that. Discuss that. Complements means no overlap between them, and they're the only two options. So the A and the B have to fill up the entire square. Mutually exclusive just means no overlap. Doesn't necessarily mean that one's option. So no overlap means it could be this, or there's a whole bunch of other possibilities, or it could be that. That doesn't happen. So when I say mutually exclusive but not complements, you want two things that can't happen together, but they're not the only two possibilities. So like you get an A in this class, you get a C. You're in this room right now, you're in Miss Mahaney's room right now. Two things that cannot overlap at all, but they're not the only possibilities. Can't be like and. That was definitely possible. Then we want to like share theirs and see if it's okay. Wants to share them, like yeah.
Riding bike to school one day and driving to school the same.
Okay, I'm glad you said the same thing. So you could, well, you can't do both those at the same time, but you can also like walk. Why?
I said like bike to school one day and walking to school.
Same thing, right? Okay. Alright. 3, 4, 5, 6. So I did a Venn diagram and showed the formulas because some people like different ways, but some A or B. If I made the Venn diagram, how do I, that point 3 goes first. And then I know A is 0.5, so that leaves 0.2 to go there. I know B is 0.7, so that leaves 0.4 to go there. If I add up all those, that gives me the OR. And then the remainder, like whatever's left over between that 4 and 1 goes here. So the OR, you can do it the Venn diagram way, just add up those 3 and get 0.9. Or you might have done the formula way, and set A plus B minus the overlap. You still get 0.9. A given B. So look at this two ways also. Given B means I know I'm in that B circle. So how big is that B circle? 0.7, right? And in that B circle, how much of it is A? If we know we're in the 0.7, how much of that circle is A? 0.3. So 0.3 divided by 0.7. Or if you're looking at the formula, it's the probability of both divided by the probability of given. So both is 0.3, and your given was B, so 0.3 divided by 0.7. So it matches. If you can understand both, it's great. Worse, I hope you understand one of the ways. Are A and B mutually exclusive? No, because there's overlap. There's A and B. Are they independent? So remember, independent, if two things are independent, probability of A is equal to the probability of A given B. Because when I told you this extra piece of information, you got to see does that change things or not. So this is the probability of A happening in general. This is the probability of A happening if I know B is true. So did B change the probability? It did, which means they're dependent. So B had an impact. That means they're dependent, so they are not independent. I didn't really mean to show the answers to the next one. Should we just go through the next one now too, or are people still working? Still working. Go ahead. If you saw the answers. So for those 70 I did the same thing. I did the formula and I did the diagram. So if you can think about both, great. my Venn diagram first, and I gotta start with the overlap. It doesn't like directly tell me the overlap, but I know if two things are independent, then the overlap is just multiplying them together, so that's why I got the 0.54. And then 0.9 minus that gives me that, and 0.6 minus the overlap gives me that. And if I add all these up, I get 0.96, so that leaves 0.04 going out. Remember, you got 4 slots to choose from, and they all have to add up to 1. So A complement, I think, is far easier to do without the Venn diagram. Just probability of A is 9, here's 0.9, so what's the probability it doesn't happen? It's just 1 minus that, so 0.1. If you want to get really fancy and say, well, in this circle is 0.9, outside of the circle must be 0.1, that works, and I think it's fine. Overkill for most people. A complement and B complement, again, there's 2 ways. They are independent, so A complement and B complement, I can just multiply those together. So A complement is 0.1, B complement is 0.4, there's 1 minus that. You multiply those together, you will get 0.04. Or, if you go through your Venn diagram, A complement and B complement is like the meter, the outside. So going through that process also gets us 0.04. Again, if you understand both, it's great. You can kind of see how they relate. If you're understanding a little bit, but if not, if you can do one. Questions? Oh, yeah, let me finish that. So B given A, 2 ways you can do this. So we got the formula. The formula is always the probability of both divided by the probability given. Both, I already found out, was 0.54. Probability given, so A is 0.9. If I divide, I get 0.6. How else could I have gotten 0.6? Much shorter. No calculation. Yes, good. This tells me A and B are independent. So I know the probability of B is 0.6. If B and A are independent, what influence is A going to have? None. It's not going to matter at all. This is like saying the probability of rain today is 0.6. Okay, great. Well, what's the probability of rains if I eat cereal this morning? That's not going to change the probability of the rains. Those are independent. So you could have just said, well, that's 0.6. They're independent. So A doesn't do anything, and that's 0.6. Or maybe you're more comfortable going through like the formula. Either way. Questions on anything on the warm-up? Yeah. Because I'm just looking at that alone. So A is happens 90% of the time, which means it doesn't happen 10% of the time. Anything else? How many, if that were a quiz, would be Let me try again. How many if I were going to give you a similar thing right now, think you would do fine? If I give you some of this. I'm not going to. No, no pop quiz. I'm trying to get right to you of your understanding. Okay. Turn it over. Do these at least one, probably. So at least once, and never, are compliments. Have you ever gone to a concert? You've either gone at least once, or you've never gone. Have you ever smoked a cigarette? You've either done it at least once, or you've never done it. When I was in high school, you like 18-year-olds would get to go outside at lunch and like smoke. The teachers didn't have to go outside. It was like a teacher lounge that was just smoke billowing. So anyway, I'm going to give you a 10-question test. How many do you get right? At least one or none. So those are opposites. So at least one is really hard to find. So in a 5-question multiple choice question test, ABCD, so 0.25. What's the probability you get at least one correct answer? So one way to do this, which we're not going to do, if you go through and find what's the probability I get 1 correct, plus what's the probability I get 2 correct, plus what's the probability I get 3 correct. Well, I can't even finish on so forth. I don't want to do that. That's a pain and it's hard. So what I'm going to do is find the probability I get none correct, and then do 1 with that answer. gonna find the probability that I get 0 correct. So I'm gonna do 1 minus the probability of 0 correct. So the probability of 0 correct. If I'm guessing on consecutive multiple choice questions, does one guess influence the next guess? No. So are they independent? Yes. If events are independent, how do I find the probability of them both happening? If events are independent, how do I find the probability of them both happening? Both time together. It'll be like the half and the half. So for this one, I've got 5 questions, so it's like 5 separate events. And then you're going to be multiplying all of those. There's a shorter way to write this. I'm just going to try to explain the process first. So if I get 0 correct, so the first question, I cannot get it correct. What's the probability I don't get the first question correct? 3 out of 4, right? And I'm guessing there's 4 choices. I'm right away. Of course, what's the probability I get the next question wrong? 4. Probably the next question wrong. 4. So some people would write it like this. 1 minus 3/4 of the fifth. It doesn't matter. You can write it either way. So I get that the 1 minus 0.237, which is 0.76. This is the probability of getting 0 correct. So if I didn't get 0 correct, I must have gotten at least 1 correct. So that's why I can subtract that out to get to that my final answer. Try to number 2, or you want to try number 2? Try number 2. And I'll still do it, but you try number 2. One left. Oh, what was the question? So what's the probability of 2 or lower at least once? So I could find, I don't know how, I do, but you don't yet. To find the probability of 1, 2, 3, 4 successes, but that's a lot of work adding up those 4 things, finding those 4 things. Hey, I'm not going to do that. Instead of finding at least once, I'm going to find never. So I'm going to subtract out 1. So for never, that means I want to fail all 4 times. So 2 or lower is success. So if I get a 1 or a 2, that's success. 2 out of the 6 things on the die, I succeed. But I want to know the probability much as I can answer, like, where'd you get it? How'd you get it? Where'd this come from? All right, be free. Some people, this seems so negative, and never all failure. Some people, I think it works better in the brain if you say you're failing every time. So never, because you're trying to find like the probability of failure. And then you want to fail, 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 fail. These are the same phrasing, it's just like whichever one works better for your brain. So we want to do, again, I'm not going to find one, I win once, I win twice, 3, 4, 5, 6, 7 times, add them all up, which is not reasonable. So I'm going to find the probability we would never succeed, take that out, and that'll leave me with at least one. So that's 1 minus the probability that I fail every time. What's the probability I fail on any one of those days? In this case, lose, I don't win. 0.99. I want to fail 7 times. So I get 0.93. No, so minus that. So I get 0.0679. We talked about rounding yet? So in AP Calc, it's very like straightforward. They say round to the third decimal place. In AP Stats, they tell you round to where it makes sense to you. Does that mean anything to anybody? Like I was in an auditorium with like one of the teachers, and I raised my hand. I was like, "What does that mean? Like, it'd be different for me and you." And well, you have to learn that. So my advice to you is, if you are not sure if you should round, don't. Like I almost want to just be a smart ass. Be like, all right, here's where it makes sense to me. Just write out every single, like. And it's just such weird advice. I don't know that. Anyway, question on the actual problem. Okay, I'd like you to go out your con and use the rest of the time to work on your con. And that does not mean use the rest of the time to do whatever. It means please work on your con. This unit is tough for people. I need you to be present in front of me so that if you are stuck, I can help you.